In this video, we will look at some terms that we use to talk about the properties of periodic functions, and specifically sinusoidal functions. So to start off with, what is a periodic function? Well, here's an example. A periodic function is basically a function that repeats its values at regular intervals. So if I start here along the y-axis for this green graph, basically it's going to go up, over, and then down, and then up, over, and down. And it continues to repeat this pattern at regular intervals, right? Approximately every 3 units, right? So from 0 to approximately 3, and then to 6, and then to 9 approximately. So this is what a periodic function would be. Here's another example of a periodic function. Okay, and again, it's a function that repeats its values at regular intervals. So if I start here at the minimum, it goes up and then about down halfway, and then up a little bit, and then down all the way. And essentially this sort of double mountain sort of image repeats again and again and again. And so that's what makes it a periodic function. You can't say the same thing about a parabola, and you can't say the same thing about a line, because both parabolas and lines don't have repeating pieces. Okay? But the star of the show, or the periodic function that I really want to talk about, is this guy right here. This is a sinusoidal function. Okay? Yeah, a sinusoidal function is a function that can be produced by transforming a sine function, right? So you now know what y equals sine x looks like, and in fact what I have here is y equals sine x. This is a sinusoidal function, which is a specific type of periodic function. Okay. Now, of course, I can transform this sinusoidal function by adjusting the vertical stretch. I can adjust the horizontal stretch. Okay. I can translate it left and right, and of course I can vertically translate it as well. In fact, let's vertically translate it up here a little bit. Okay, and then we'll talk a little bit about the terms that we use to describe the properties of this graph. Okay, so the first term that I want to talk about is what is called the median or the midline of this graph, right? And so I've just turned it on here. It's the green line. And really what it is the midline is the horizontal center line about which the function oscillates above and below. And another way to look at it is that it's really the line that splits the graph into an upper half and a lower half. Okay, and as I adjust the vertical stretch, of course, the median or the midline changes, right? So if I had not translated it at all, then the x-axis itself would be the median. Okay, otherwise, the median is essentially whatever the vertical translation is. The next property to introduce is the amplitude. And now that I've got the median or midline established, the amplitude is really easy to define. The amplitude is basically the distance from the midline to the maximum of the graph, right? I guess you can also define it as the distance from the midline to the minimum of the graph. That is what the amplitude is. And then a third way to define it is, of course, is to say that the amplitude is simply half the height of the graph, right? If the height of the graph extends from the minimum to the maximum, then the amplitude is half of that distance. Okay, and the amplitude, you should know, is always positive. Okay. The next term to define is a cycle. So a cycle would be basically the one complete repetition of the pattern in a periodic function. Okay, so actually let me put the median back on. So if I start here, in fact, let me put a point on it. We'll use this point right here. So if I start right about here, okay, if I start here at the beginning of the orange spot, and then I move through the graph until this spot right here, actually a little bit here, let's make this a little bit more, hang on one second here. It doesn't look like I can quite get it on that point, well, maybe right there. But basically, as I move this point along this piece of the graph, I will be able to get through the orange section before the pattern repeats. So one complete repetition of the pattern in a periodic function is called the cycle. So from this point all the way to this point is one cycle, because as you can see, it just repeats from here to there, or on the other side, from here to there. Okay, and then this leads us into our final definition, which is what a period is. Okay, so a period is precisely the width of a cycle. Now, a cycle does not have to be defined from a particular point that's along the median until the next time the pattern repeats. The period can also be defined as the width of a cycle from maximum to maximum. It can also be defined as the width of a cycle from minimum to minimum. All three of these ways of defining the period are legitimate because they're all equal. To show you that they're all equal, I'm just going to adjust the period a little bit to something that's a little bit more easy to uncover. Now, if I look at the maximum to the maximum, okay, so from this point to this point, that's about 4 over, as you can see. And then if I try to measure the distance from here to here by shifting this over, it will also be 4 units. And then if I measure the distance from the minimum to the minimum, that will also be 4 units. Okay, so the colored part is considered one cycle of this graph, whereas the distance or the width of one cycle is considered the period. Okay? And those are some of the terms that we'll be using moving forward in our study of sinusoidal functions.